this packet. So page 12, page 12, page 12. Page 12.
Page 12?
Up page 12.
Page 13.
Oh. All right.
That's one less than 13.
A frequency table groups data values into intervals. The frequency is the number of values in each interval. So the data below represents scores on a math test. So as I find something in that frequency, I'm just going to make a tally and then I'm going to add the tallies up. That way we can figure it out, okay? So on page 12, I'm looking at example 1 here. 81 belongs in this interval, right? So I'm going to put a tally and cross it out so I know I've accounted for it. 55 belongs in this top frequency, so I'm going to put a tally and cross it out. 100 belongs here. 94 belongs in that same spot. 61 is in that second spot down. 80 belongs here. Bless you. 77, bless you, belongs in that same spot. Same with 74. 92 is all the way on the bottom, right? Between 91 and 100. Same with 95. 52 is on the top. 86 is second from the bottom. 90 is in that same one. 78 is right above there, right in the middle. 81 makes 4 for that second in the bottom. 100, notice this is the fifth one, so I go across. That's how we make tallies to help us count them up more easily. 65 is in the second from the top. 81 is second from the bottom. That makes 5 there. 70 is second from the top. And 94 is in this one in the bottom. So if it helps you to write the numeral, you may do so, right? So there's 2 in this interval, 3 data values in this interval, 4, 5, and 6 data values in that final interval. That's it. Yep. So the data below represents number of laps around a track. So we're going to organize it the same way. So 7 is in the second one. So I'm going to put a tally there. 10, same thing, same spot. 1 and 3 belong in the top. So 2 tallies there. 8 is in the second. 17 is going to go all the way on the bottom interval. 12 is right above there. First one in that box. 2 is on the top. 10 belongs in the second interval. 9, same thing. That makes 5, so I'm going to cross it. 15 is it right below there. 13 in the same box. 9, second from the top. 12 right here. 8 right above there. 4 in the very top. 20 is all the way on the bottom. 7, second from the top. 14 makes 5 in that 11 to 15 category, interval rather. 2 is on the top, that's 5 there. 10 is right below there. 3 is at the top. 17 all the way on the bottom. 6 makes 10 in that 6 to 10 group. 2 is on the top. And 15 is second from the bottom. So you can see this occurs 7 times. This occurs 10 times. This occurs 6 times. There's 6 data values in that interval, and there's 3 data values in that interval. Notice there aren't the same number in every interval, but as long as these are the same and these are the same. So there's 10 numbers here, 5 numbers here, right? 5 in each of these, 10 in each of these. So your table needs to have intervals that are the same. All right, so we are going to make a list of all the values from the frequency chart. So number of awards won by a movie. So 2 happens twice. So I would write 2 how many times? 2 times. 3 happens twice. So I'm going to do the same thing here. 4 happens twice. And I'm going to list all my data values. 5 happens 3 times. 6 is once. 7 is 4 times. And 8 is once. So if I listed all these values, this would make it very easy for me to figure out my range, right? High minus low. My median, find that middle number. My mode, what occurs the most. And then I would add them up and divide by the number that there are to find the mean, right? Hey, diddle diddle, the median's the middle. We add and divide for the mean. The mode is the one that occurs the most, and the range is the difference between. Questions on page 12. Just a matter of doing it, right? Hopefully, nothing too complicated as far as concepts go. All right, 13. Find the mode, median, and mean for each data set. Notice we don't have an interval here, so we know that there are 3 of these. So let's list our data. 1, 2, 3, 4s. How many 6s? 1, 2, 3, 4 6s. And how many 7s? 9. 4, 9, 6, 7. Uh-oh. That got kind of ugly. I needed to write smaller probably. The mode, what occurs the most? We can tell by the frequency table, right? What's our mode here? What occurs the most? 7. What is our median? So if we started on the outside and we worked our way to the middle, bless you. 1, 2, 3, 4. It looks like our middle number is also 7. We add and divide for the mean. So we're going to add all of these up. Grab your calculator. And we're going to divide by the number of data values. Add them all up. And then what are we going to divide by? It looks like 7 plus 9. Then we're going to divide by 16. There's 16 data values. 4 plus 4 plus 4 plus 6. I could have said 4 times 3 times 6 times 4. No, plus 6 times 4. I said that wrong. Plus 6 plus, and I need 9 7s. 7, 2, 3, 4, 5, 6, 7, 8, 9 7s. Did you get 99? All we're doing is adding at that point, and then we're dividing by 16. Make sure you put equals. So 99 divided by 16 is equal to 6, we'll say, and 2/10. We'll round to the nearest decimal. It seems reasonable, I suppose, right? All right, here's our age at our first job. I'm going to start listing them. 11 occurs once, so does 13. 14 occurs 3 times. 15 occurs 4 times. 16 occurs twice. 17 occurs once. I'm going to have to use another line. 18 occurs twice, and 19 occurs once. All right, mode. What occurs the most here? What occurs 4 times? 15. Median. Remember, think about the median of the road. It's the thing in the middle. So I'm starting on the outsides and working my way in. A 13 and an 18, a 14 and an 18, a 14 and a 17, a 14 and a 16, 16 and a 15, and our middle number is 15. Mean. Hey, diddle diddle, the median's the middle. We add and divide for the mean. I need to add all of these data values up. All right, I got 230. What did you guys get? And I got 15 data values. So I'm gonna, after I hit enter, remember we have to add them all up first and then divide by the number of values we added. So 15.3 repeating. So 15 and a third. That seems reasonable, right?
Wait, who was 11 for third job?
I don't know. Maybe they worked on a farm or something, or at a family business. Goals in a hockey game. So again, remember, this is the data value and this is how many times it occurs. So I have to include 4 2 times. This is the data value and this is how many times it occurs. So I need to include 5 4 times. Don't get confused by what is what. 6 only occurs once. 7 occurs 3 times. 8 occurs once. 9 occurs twice. Do you see how it's important that you learn to write neatly and efficiently? Most of your time is spent writing down your problems. That's a lot of goals in a hockey game. 12. All right, mode. What occurs the most? 4 was the highest frequency. So that data value that occurred 4 times was 5 goals. The median. Hey, diddle diddle, the median's the middle. Work your way from the outside in. Looks like 7. Anybody get something else? We add and divide for the mean. So again, I'm adding these all up. Oh shoot, or clearing it. All right, when I added them, I got 103. Let me know what you got. And I have 15 data values again, I think. That seems reasonable to me. What do you think? Did anybody get something different? No. All right. 4, we're doing the same way. I might take a shortcut here and what occurs the most? Well, 8 is the most something occurs, and that data value is 1. The median is the middle. So there's 8 ones. There's 1, 2, 3, 4, 5, 6, 7, 8 other data values. So between If there's 16 data values, we need between a 1 and a 2. So what's between 1 and 2? What's the mean of 1 and 2? 1.5. If you wanted to draw it out, you could. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 3, 4, 5, 5, 5. And 11. That occurs once. So 1 and 11, 1 and 5, 1 and 5, 1 and 5, 1 and 4, 1 and 3, 1 and 3, 1 and 2. So between 1 and 2, remember we add them up and divide by 2. So 3 divided by 2 gives us that 1.5. All right. You add and divide for the mean. Well, 1 times 8 is 8. So I'm not going to put that in 8 times. 8 plus 2 plus 6. 3 times 2, right? Plus 4 plus 15 plus 11. So 46. We said there were 16 data values. 2.875. What made my mean so much greater than my mode and median? Any ideas? This right here, right? That 11 made my average go way up. Even though it only occurred once. All right, questions about frequency of things. How we use a frequency table to find our measures of central tendency. All right, stem and leaf plots. This is one hopefully you've seen before. We definitely did this in 6th grade, but a stem and leaf plot is a way of organizing and displaying data using the digits of the data values and seeing how the values are distributed. So the last digit of the data value is the leaf. So this digit might be in the ones place. It might be in the tens place. It might be in the tenths place. So it might be a decimal value. The remaining digits are the stem. The key will explain what the stem and leaves represent. So this key shows that 2/1 is equal to 21 minutes. So each of the stems are what place value? The tens place, and the leaves are all in the ones place. So this 0 doesn't represent a 0 here. It represents the number what? 10. The 3 and that same $13. Good. The 6 is 16. This 3 down here is 53. Good. So this shows the length of a set of customer service calls. What is the mean call time? So if we're thinking about what we needed to put into our calculator, this leaf represents the number 9. Then we have the numbers 10, 13, 2 16s, right? It's helpful, especially if they're going to ask us what the median is, to just write them all in order. But you can also use the stem and leaf plot. So I'm going to show it both ways. This is 21, 24, 32, 41, 47, 53. So these are what this is representing. So from this stem and leaf plot, I could have just put them all in like that, right? But you have to sometimes think through that. 9 plus 10 plus 13. So we're going to add them all up. I got a nice even number. And there were how many leaves? The number of leaves tell me how many data values I have. So there's 5, 6, 7, 8, 9, 10, 11, 12. So the average call time is 25 minutes. The mean, now look at from your leaf perspective, the 9 and the 53, the 10 and the 47, the 13 and the 41, the 16 and the 32, the 16 and the 24, the 18 and the 21 are our middle two. So I would have to say 18 plus 21 divided by 2. If I have two middle numbers, I need to find the mean of those two numbers. So 39 divided by 2, I'm going to have a half of something, right? 19.5 minutes was the average. No, not the average, the middle call time. The median is the middle. How many calls were more than 10 minutes? So that's all of these leaves here, right? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 calls. How many calls were at most 30 minutes? At most means 30 minutes or less. That is all of these minutes. So 1, 2, 3, 4, 5, 6, 7, 8 calls. You see where I'm getting those from? At most. If it's at most, that's like your speed limit. Your limit is 30. 30 or less. Less than or equal to 30 minutes here. Okay, the stem and leaf plot to the left shows the ages of the players on the hockey team. Median age. So again, 19 and 36, 21 and 34, 22 and 32, 23 and 31, 23 and 30. And then we have two middle numbers. So this middle number is 25 and 27. Notice the biggest error that I will see, I didn't say 5 and 7. 5 and 7 are not my middle numbers here. What do 5 and 7 represent? The 25 and the 27. So add those together. 25 plus 27. 52 divided by 2 is 26 would be the average. Not the average age, I keep saying that. The median age, the middle age. That makes sense because 26 comes between 25 and 27. The mode age, which one of these occurs the most? I notice this 3 is on here twice. Does anything occur twice or more? Anything else? There are 2 2s, but this 2 is 22 and this 2 is 32. Same with the ones. This one is 21 and this one is 31. So the data value that occurs the most is not 3, but 23. So be careful with that because we have to think about what those values are representing in our stem and leaf plot. The range of all ages. Now, again, you might be tempted to say 9 minus 0, but really our eldest age is this 36, and our youngest age is that 19. So 17 years between the oldest and the youngest. How many players are at least 25 years old? So this means greater than or equal to 25 years old. So here's a 25-year-old, and everyone older than that is what we're counting. So 2, 3, 4, 5, 6, 7 players are at least 25, right? 23 would not be included in that. Neither would 19 or 21 or 22. Does that make sense? If you're not sure, think about each of these numbers as it applies to the question. All right, we've got some practice. Well, I guess we can keep going. One more page of stem and leaf plots for you. So this just repeats. We have different, this isn't the same page, right? No, these are just in points of football scores. So think about the mean. We're going to add these all up. This represents 3 plus 6 plus, this 2 isn't 2, it is 12, right? Plus 13 plus 14 plus, this 1 is not 1, but 21. 2 24s into 28. Remember, down here, that 0 represents 30. There's 3 35s. You guys got to get quick at these and knowing what they mean, right? So as I'm finding the mean, I add up all of my data values. I use my key, right? It's still tens in ones place. We haven't had any different ones. It might be a little bit different towards the bottom. And I have to divide by the number of leaves I have. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm dividing by the number of values. So my average is 24 points. That seems reasonable. Median. Notice I have 16 data values. So I'm going to have 8 less and 8 more than my median. So if I count off 8, 1, 2, 3, 4, 5, 6, 7, 8. And I count out 8 from this side. 1, 2, 3, 4, 5, 6, 7, 8. I have 2 of the same number. So the number between 24 and 24 would simply be 24. What number occurs the most? Bless you. I notice there are 3 of the same thing in this row. What do those 5 stand for? 35. So that's my mode. I don't have anything else that occurs 3 times. This 4 is a 14 and the other 2 are 24s. And my range is my largest points minus my least points, which is, looks like 3, right? My tens is 0 here, so that's a 3. So my range is 42 points. That's a pretty wide range, I'd say. How many games did the team score less than 14 points? So less than 14 points would be these 4 games here, right? How many games did the team score? At least 35. So 35 or more would be everything greater than this. So it looks like there are 5 numbers there. So that represents 5 games. Question on where I'm getting these things from, because you're going to have to do this on your own in just a minute here. 7-leaf plot to the left shows the running time. Mean, median, motor range. Again, instead of this, these are still tens, but this would be 101, 105, 109, 114, 116, 118. So I'm going to go ahead and put those right in here. 94. That 0 stands for 130, right? Whew, that's a big number. 1534, and I'm dividing it by 2, 5, 8, 9, 10, 11, 12, 13. to get my mean. 118. My average. There were 13, so that means I should have 6 data values, a middle number, and then 6 more, right? That adds up to 13. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My middle number is this one right here, which is 116. What occurs the most? I see 2 4s in this row. Don't see any other doubles. And my range is my highest scoring game. Or no, what are we talking about? Time here. My highest time, 148 minutes, minus my least time. 14 minus 9 is 5. So 54 minutes there is my range. How many movies have a running time greater than 130? So that does not include 130. There are 3 there with more. How many movies are at most 2 hours? So 2 hours or less. So everything above this, right? Because 2 hours is 120 minutes. Good. 8 movies. All right, 16 and 17 are yours. Practicing frequency tables, using them. Practicing stem and leaf plots, using them. Hopefully, by doing those, we are reviewing our mean, median, mode, and range. There may be some data sets in there that you can go back and practice with as well, but I think that will give you enough practice as far as that goes. So take some time right now. Do what you can in there. Tomorrow, we're going to spend the first bit just reviewing, and then you're going to take the quick quiz on our data unit. Okay?